Keep the hand in front of the sensor. We get a notification stating motion detected and the virtual LED turns on and the buzzer turns. Values are shown in this LCD display also. Check with the flame sensor. We'll check on the rain detector sensor. Let us start with the LDR sensor. Welcome back to my channel Ibrahim's World Vision. Today I have done a basic project which is a smart home. I have done this project with multiple sensors, and with the help of all these sensors, whether you are in the home or you are not in the home, you can just be updated whether there is a fire detected in your house, whether someone is trying to enter your house, whether there is a rainfall detected, everything you will be notified. And even the night light will turn on automatically if it becomes night. It also reduces your time and it also safeguards your home. If you are watching my channel for the first time, please click subscribe and like this video so that it would motivate me to do more projects like this, and I will make more projects in future. Now let us see what are the components required. ESP32, this is the upgraded version of the ESP8266 and it has a dual core processor, and it is very fast and very helpful for IoT advanced projects. This is the main component of our video, and this is the first project I am doing with this component in my channel. A LCD display with I2C board attached. So this LCD totally has multiple pins, and this I2C board converts it into 4 pins: GND, VCC, SDA and SCL, and with the help of this potentiometer we can adjust the brightness. Rain detector sensor with its connector, LDR sensor which is a light dependent resistor, a flame sensor to detect the flame, DHT sensor for temperature and humidity, PIR sensor for motion detection, 5V DC buzzer, LEDs to represent night light, jumper wires and micro USB coding cable to code the ESP32. Two breadboard. I am using two breadboard because if you directly keep the ESP8266 on one breadboard, only one row will be remaining, so we can't connect on the other side. So I am using two breadboard. And power bank for the power supply. You can also use a 3.7V lithium battery, but as we are using this much components, I am using this power bank. Device for the Blynk app, a screwdriver to adjust the potentiometer of all these sensors. Now let us take the two breadboards and connect each other, and I will place the ESP32. Take two male to male jumper wires and connect the VIN pin, which is the 5V pin, to the positive row, which is the red line here in the breadboard, GND to the negative line. Now take the DHT sensor, connect the positive or the VCC to the positive line of the breadboard and GND to the negative line of the breadboard. Connect the data pin to digital pin number 4. Now take the LED. It totally has two pins. One is positive and another is negative. The long one is positive and the short one is negative. Now let me connect the wires to it. Connect the negative of the LED, negative row of the breadboard, and the positive one to GPIO pin number 26 or D26. Now let us take the flame sensor and connect the jumper wires and connect the VCC to the positive row and GND to the negative row. Connect the out pin to digital pin number 35. Take the PIR sensor, connect the jumper wires to it. Connect the VCC to the positive row of the breadboard, GND to the negative row of the breadboard, and connect the out pin to D33. Now let us take the buzzer and connect the positive of the buzzer to digital pin number 25 and negative to the negative row of the breadboard. Now let us take the rain sensor, connect the two pins to the two pins of the rain detector sensor, 3 male to female jumper wires, and connect the VCC to the positive row and GND to the negative row, and connect the digital output pin to digital pin number 19. Now let us connect the LCD. 4 male to female jumper wires, female part to the LCD's 4 pin. This is the VCC, GND, SDA, SCL. Connect the VCC to the positive row of the breadboard and GND to the negative row of the breadboard. Connect the SDA to GPIO pin number 21 and SCL to GPIO pin number 22. Now the connection is completed. Now let us take the LDR sensor and connect the jumper wires to it. Connect the positive to the positive row, VCC to the positive row and GND to the negative row, and connect the digital output pin, digital pin number 34. I'll just give the circuit diagram in description. You can go check it if you have missed the video, or you can also repeat the video if you are not sure with the connection. Now I have done the connection. Now let us code the ESP32. Now let me open the Google Chrome and type for Blynk IoT and click on the first link and click on login and give your login details and sign in. If you are new to this account, click on sign up and give all your informations and then click on login. Now after login it will load, and now go to developer zone and click on new template and give any name to the template. I'll just give Smart Home. And select the board as ESP32 and connectivity type as Wi-Fi. You can give description if you want, and click it and go to data streams and click on new data streams and virtual pin and type as temperature. The data type is double, and in the units change it as Celsius. And the max value is 50 and click on create. Now click on new data streams again and click on virtual pin and give the name as humidity. And the data type is double and the unit is percentage. And the max value is 100 and click on create. Now again click on new data stream, virtual pin and give the name as LDR value. And the max value is 4095 and click on create. Now click on new data streams, virtual pin and give the name as flame detected and click on create. Now click on new data streams, virtual pin and here change the name as motion detected. Click on new data streams, virtual pin and change the name as rain detected and click on create. Now click on create. Now go to new data streams again and virtual pin and then give the name as light and click on create. And here click again and give the name as button and click on create. Again click the new data stream, virtual pin and give the name as motion and then click on create. As the video's length is exceeding, I am going to separate this video into two parts. and the second part of the making of the event and how the project works, uploading the code, everything will be uploaded in my channel soon. Until that, stay tuned and subscribe to my channel and like this video and comment in the comment box what video should I upload next. Bye.